Hi, let's continue with Lagrange multiplier. So last time we did some examples, and when we solve system of nonlinear equations, the process could be very long because we might have different cases, and in each case we might have different subcases. So we have to be patient and do it slowly and make sure we include all the cases, all the possibilities, okay? So let's look at this problem. F is the level surface and we have the constraint. So we can define G to be the left-hand side minus the right-hand side. Then what is gradient of F? Well, derivative with respect to what x is y is z, derivative with respect to y is xz, derivative with respect to z is xy. Gradient of g is 2x, and then 4y, and then a z. Okay, so we want to have the Lagrange system, and let's see. Lagrange system and g equals 0. Okay, and last time we talked about if the gradient of g is 0, we could have singularities, but you can see here gradient of g is only 0 at the point 0, 0, 0, but 0, 0, 0 is not in the surface of g equal to 0. So in this case, all the possible maximum and minimum values should be included in the solution of the Lagrange system. Okay, so let's see. Yz equals lambda times 2x, xz equals lambda times 4y, and xy equals lambda times 8z. At the end, x squared plus 2y squared plus 4z squared equals to 9. Okay, how do we solve this system of equations? Okay, so let's first get rid of lambda. Okay, I use equation 1 over equation 2. Let's see. Then we will have on the left hand side z cancel, y over x, lambda cancel, so x over 2y. So far so good. And we can also use equation 2 and equation 2 over equation 3. That will give us x cancel, z over y equals lambda cancel, y over 2z. Okay, so now you can see we eliminate lambda and we get 3. We get 3 equations and 3 unknowns. We should be able to solve it. So the first equation is the same as saying x squared equals 2y squared. So let's move everything on the left hand side. Well, what does that mean? Well, it means this is the same as x plus square root of y, x minus square root of 2 of y is 0. So we have x equals negative square root of 2y or x equals square root of 2y. So see, we have 2 different cases. Okay, let's see here. And then let's see here. From this equation, we have 2z squared equals y squared. So y squared minus 2z squared equal to 0. We also have y plus 2, mean y plus square root of 2z, y minus square root of 2z equal to 0. So y equal minus square root of 2z, or y equals square root of 2z. Okay, so far so good, everybody. Okay, so because each equation gives us 2 subcases, now we actually have 4 possibilities. Yeah. Okay, so what are those 4 possibilities? Okay, let's see. The first possibility is x equals minus square root of 2y and y equals minus square root of 2z. Okay. Second possibility is x equals minus square root of 2y but y equals square root of z. Third possibility, x equals square root of 2y, y equals minus square root of 2z, x equals square root of 2y, y equals square root of 2z. So those are the 4 possibilities. So let's plug into equation 4. Okay. And, oh, you see in this case, because y equals square root of 2z, so square root of 2 times square root of 2 is 2z, okay? So in this case, we get x equals square root of 2 times square root of 2 is 2z. Here, we have negative 2z, right? And then here we have 2z. Okay, now we can plug x and y in terms of z. You can plug in 4. Okay, so x squared 4z squared 2y squared is 2z squared, right? Plus 4z squared equals 9. Oh, so we have 3 copies of 4z's. So that's 12z squared equals 9. Z squared, we can divide it by 3, then we have 3 over 4. Z is plus or minus square root of 3 over 2. Okay, we have 2 points. First, z equals square root of square root of 3 over 2. Next, negative square root of 3 over 2. And then here, the x is 2z, so 2 times that is root 3. Okay, y is negative square root of 2z, so negative square root 2 and 2 cancel. We have square root of 3 over 2. So far, so good, everybody. On the other hand, well, we flip the sign, so negative root 3, negative root 3 over root 3. So far, so good, everybody. Okay, let's continue. So this guy, we plug in 4. X squared, still 4z squared, plus 2 times, still 2z squared plus 4z squared. Because it's squared and then the odd and negative just become positive, you can kind of expect all these cases our z will be plus or minus root 3 over 2. But then in this case, minus root 3 over 2. Okay, well, our x is negative. X is negative root 3. And y is positive. So you can see the number is the same. The difference is whether we have the sign. And this is negative. Okay. And here we know z is gonna be plus or minus root 3 over 2 as well. So what are the points? Root 3 over 2, negative root 3 over 2. Okay, x is opposite sign. This is plus, then this is minus. Y is opposite sign. This is plus, this is minus. And opposite sign, so plus and plus. Is that okay, everybody? I know it's kind of fast, but because the number, you see all this guy are square, so it means, because the different cases, the difference is just some signs has the negative, right? But when we plug in like the square, our z is always plus or minus root 3 over 2. Then we can plug in the x and find the x and y. Okay, so z is plus or minus root 3 over 2. Yeah, we have a lot of solution in the Lagrange system. So let's see which ones is maximum or are maximum, which ones are minimum. Okay, 2z. Okay, so this guy is the same sign. So same sign. Here, same sign. Okay, or different sign. Okay. Okay, now we have find 8.8 solutions. So 8, we have 8 points. Okay, that we need to check the f value. Okay, so let me use a different color. What is my f? So our f is x times y times z. Okay. Let's see. This guy, my f will be multiply them all together. So negative plus minus plus will be negative. And then on the numerator, root 3 copy of root 3 multiplied together is 3 root 3. The bottom is 2 root 2. Is that okay, everybody? And here you can see we have 3 negative multiplied together is still negative. But you see the number is gonna be the same. It's just the sign could be different. So 1 negative still give us negative. 2 negative, see? 2 negative will give us positive. And here, 2 negative give us positive. Here, 1 negative give us negative. Here, all positive give us positive. Here, 3 negative give us negative. Ooh, okay. So, let's come back. What is this guy? So let's draw it. We know it's like ellipsoid, right? It's not a sphere, but ellipsoid. So I want to show you because here I can use the GeoGebra and help us to draw a nice picture. Okay, so that was our previous one, so let's deselect it. Okay, so x squared plus 2y squared plus 4z squared equals 9. See, this is the ellipsoid. Okay, the you know, on the x direction we have the axis equals the x-axis at 1. Y, first of all, in order to find the major and minor axis, we need to divide both sides by 9 and then look at the denominator and then take square root of that. So anyway, this is the ellipsoid. It looks like an egg. Easter egg, duck egg, chicken egg. Okay, so this is the constraint. All right, the constraint. And next, what is x, y, z? Okay, we want to draw level curve. So x, y, z equal to 0. Oh no. Let's see. Oh, okay. That is not quite possible. because they just give us lines. It could be 0, 0, y 0, and x 0, just like the three s's, right? And the plane. Z0 is the xy plane, y0 is the xz plane, x0 is the yz plane. Okay, so not that one. How about xyz equals 1? Let me see. Okay, it turns out I have to type z equals 1 over xy. Okay, and we can have z equals 2 over xy. Okay, we can make this number bigger. Let's use 5. Or can we make even bigger, 15? Okay, then can you see the level curve? Okay, so this is the level curve. Can it be negative? Can z be minus 1 over xy? Yes, it could be like that. You see? So that's why we, on the constraint like the ellipsoid, we can get maximum and minimum values. Okay, so okay, this is so this is a picture, right? And let me print screen my picture on the handout. Then, oh wait, actually in the process I don't need this one, so let me delete this. I don't want to confuse you, so delete that. So okay, here are the information we need. Okay, all right, so those maximum are really the maximum, those minimum are really the minimum. Okay, do I have here, let me do test in front of test. Okay, so let me make it smaller, and I put it here. Okay, okay, so then you can see this picture in the notes. Okay, all right, so yes, let's come back and the notes. So all of those, here the positive, the minimum, the negative is the minimum. So this is minimum, this is minimum, this is maximum, this is maximum, this is minimum, this is maximum, this is minimum. So see, we have 4 minimum. Do I make some mistake? It should be 4 minimum and 4 maximum. Okay, let's see which one we have mistake on. Okay, I found a mistake. This guy. So x is in the same sign of z, but y is different sign. So this should be positive. This should be positive. So this should be a maximum. Yeah, you can see each pair we have maximum and minimum. So also now the first pair also we have a maximum and minimum. So far so good. So we get 4 maximum points and 4 minimum points. Okay, or maximum fi. So 4 points we get the f achieve maximum values, and we have 4 points f achieve minimum values. Okay, so yeah, I hope you like this example. You can see this process. We might, depending on the difficulty of the system, because it's not linear system, it's not like we have we have fixed way to solve it. So how do we solve the system really depends on the function, and how many cases also depends on the function. Here we have 4 subcases. It gives us 8 points to check. Yeah. Okay, so that's it for today. So please do your homework and then ask me questions. When you have time, do the practice exam and more exercise from your textbook. Okay, so Calc 3 is not easy, so a lot of exercise, and also play with the GeoGebra software. Then we can increase our understanding when we visualize those surfaces in the 3-dimensional space. Okay, so that's it for chapter 12. Have a nice day. Bye.